Hey everybody, and welcome back. Um, Today I am tempting fate. So one of my viewers and one of my Patreons also, Neil's Hobby HQ, sent me this kit. I think to thank me for sending him a basically this kit, this one here. But I feel like it's more of a punishment. Of course, I'm thrilled to receive a kit, but this is a Tesla coil kit, and high voltage and medium voltage scares the crap out of me. So thanks, but just kidding. Thanks, Neil. Um, I'm a little afraid to do this, so I think I'm stalling for time. So I think I should just get at it. It's a very simple one. Actually, it's the only one I could find on eBay, or one of the few I can find on eBay with just one heatsink. There's nowhere to put a audio jack in, which is great because I live in Canada. Healthcare is free. Well, that's pretty. I don't have to pay extra for it if I get hurt. That's fine. But my phone costs me a lot of money, so I don't really want to risk it. So yeah, here we go. It doesn't have any values or anything on. It just says resistor, capacitor, Q1, the terminal, the LED, a couple, couple places to solder this, and yeah. Well, I'm mildly terrified, but here we go anyway. This resistor, um, yellow purple 47, black is 0, so 470, and then the red add 2 zeros, so 47K is this resistor. Look at that. Look at me learning my resistor codes right before I have to go to the ER. Okay, those two. Might as well stick the switch on here. Does it fit the other way? No, thankfully. Okay, I'm going to grab a little bit of sticky tack, hold that switch in place. Basically, I'll do this in 3 steps. I'll do the jack, the LED, positive of the LED is the little one, not the anvil shape, and it's also a longer leg, so it goes here. So yeah, I'm going to do these components, then I'll do the heatsink and transistor, and then I will do the inductors, and then that should be it. I'm hoping to not keep you guys too long before I get annihilated by high voltage. So if you came here to see my demise, don't skip ahead. It's coming soon enough. Okay, and now I guess I'll anchor this with a little bit of tack. How's that? I'm a little bit zoomed out more than usual. Hopefully that's okay. I figured this thing can be pretty tall. So yeah, also I had to go look online. Alice is selling these, Alice 110 1983. If you want to subject yourself to that. They're not very expensive. And they require 12 volts, so we're well suited for it. I can definitely provide 12 volts. Okay. This needs a little bit more heat, this terminal here. Get that nice and melty. Seems like a quick kit to build. The other one with more complexity, 2 heat sinks and whatever, would have taken longer to build. So this is nice and short, but at the same time I can't delay the inevitable for too much longer. Not sure how I feel about that. If you guys are happy at the fact that I'm terrorized, then down in the comments below, go say thank you to Neil's Hobby HQ. If you want to support my widow after I perish from this, make sure to join my Patreon. I'm pretty sure she has access to it, so yeah. Or if you just want to see me do a bunch of crazy stuff that costs a little bit more money, that would be great, just to throw $1 in the pot. I've actually met some pretty cool people over Patreon, so that's pretty good. YouTube advertisements certainly do not pay the bills. They don't even offset. I'll tell you, the money I make on a mailbag video doesn't even offset the cheapest item in the mailbag video, just to let you know how much money I make on YouTube. It's interesting the LED is here because it goes to the secondary winding and to this 47K. Was it 4.7K? Yeah, interesting. Interesting. Okay, so that's done. I will now do this much taller component. So I'm guessing this needs a screw. What's that, Phillips? Close enough. It's probably some sort of, oh, that's not a good fit. Probably some sort of Chinese Phillips alternative. Here in Canada, we have Robertson screws, mostly for woodworking, carpentry, and stuff. And you know, I really like the Robertson screws. They're really nice because they hang on to. You don't need a magnetic screwdriver. They just happen to hang on extremely well. Maybe I should increase the heat on my soldering iron because this might be a little bit more challenging. Get the heatsink red hot. Oh, we'll see. One of these leads is connected to the heatsink, so hopefully I'll be able to get it soldered in. That wasn't too bad. Here's the tough part though. Trying to get the pad and the heatsink heated up. Flow some solder in to get more contact area. This is not uncommon to be challenging to solder. Come on, you can do it. I think this is a 45 or a 65 watt iron. Oh boy, this is sucking all the heat out. Just trying to bring some solder to keep the flux running. Yeah, this is super challenging. May have to come back in. Oh, I think it's melting. I think I got it. Let's go on the other side. Play on the fact that the heatsink is still warm. You can preheat these heat sinks with like a, let's say like a hot air gun or something to try to make this easier to solder. But the deal is, it's just a pain in the butt for everybody. You need quite a bit of power. Give it as much working surface as possible. A lot of pressure also. Make sure it's transferring the heat. I'm sure the iron, the base station, is pumping out all the available heat. Oh, I can feel it sticking, so it is melting, but not super well. But that's what heat sinks do. You can't get mad at a heat sink for doing its job. I might crank up the temperature a little bit. This at 350 C. I'm going to go up to 450 C. It'll just give me a little bit of a head start on the heat sink. Is that warm? Yeah, that's quite warm. Hopefully I'm not going to damage the transistor in the meantime. But giving your iron a little bit more temperature will increase its heat a little bit when it comes time to flow that solder. There's a big difference between temperature and heat. You can think of temperature as the number, like the actual degrees, but the heat is the total amount of sort of energy you're bringing to the game here. All right. Yeah, see, look at that. Heated the solder instantly. Might be struggling to keep up now. Is that hot? Oh, it's warm. Yeah, it's definitely hotter than before. Okay, I'm going to lift off. Come over here. While the heatsink is hot, flow a little bit more solder, not too much because it's going to cool down the whole assembly. I'm going to drop my iron back down to 350 so that the tip doesn't oxidize too much. This whole assembly is hot now. I don't know if you can tell, but yeah, that is very hot. Okay, so now have to solder this guy. So there's two leads, one on each side. They're about the same length. I don't know if you can see that. Maybe just barely. This one's a bit longer, so I'll keep the long end. It seems as though I need to solder L2, which is this guy, into a hole here. And then I may need to glue this down. I'm not sure how this works, because I don't want this flopping around. So I may actually just hit that with just a touch of crazy glue. Crazy glue, of course, is a name brand of cyanoacrylate glue. And whatever you do, don't buy them in big containers. You just want these little guys here. I'm going to put a fillet there and there. And as long as it doesn't go into the solder holes, I think we're going to be good. I'm going to give this a few minutes to set, and I will bring you back then. Well, the crazy glue is not quite dry, but it's close enough. This is pretty solid now. This is very awkward because it's going to be hard to solder on the other side while putting pressure on these joints here. But we're going to try anyway. And we're also going to see how many turns of this wire we can get around there. I only need a small length of insulation stripped. This is solid core wire. Does it say? 1.5 square millimeters. I don't know what that is in American wire gauge. I put way too much crazy glue on there. So just going to try to, I don't want to form this over. It looks like I can only get one turn actually. I don't want to form it over the actual coil because this enameled wire is super fragile. So let's see. Run this over like that. Really don't want to rub the enamel off. Yeah, you get like barely enough wire to make a full turn. I'm not even sure which direction it's supposed to be wound, but that's alright. I'm sure it'll be just fine. So I'm going to tilt this down. I think I'm going to solder this down and then shape it the rest of the way. There's barely enough wire here for a full turn. I also want to make sure the insulation is well and truly down to the hole here. There we go. I don't know if you'll be able to see that. Well, you're just going to have to imagine. Plus, I forgot to turn on my soldering iron. Fantastic. Well, I have to get this enameled wire hot enough so that the enamel will actually melt and allow me to make a connection here. So I'm just going to hold the iron up to it, put some solder in there, and then actually hold it on there a bit longer than strictly necessary to try to burn off that enamel. Hopefully that'll make contact, and if it doesn't work then we'll know why. I'm going to trim the excess here because I don't want that arcing over underneath. I think that's well and truly soldered in there. I hope so. Same time, don't want to get it too hot. Alright. Now for the L1. Yeah, if you're going to use super glue, use a bit less than I did. That was a bit excessive. Not the end of the world, but it just it took longer. I actually took about an hour break to let it dry, and it's not entirely dry, but it's dry enough that it's holding quite well. Get this nice and hot. There we go. I believe that is soldered on. It does look like it is. Just going to snip. Yeah, that went flying to all corners of the room. Now I'm going to try to ease this part of the wire into submission. It doesn't look very cooperative though, and I don't want to break off the crazy glue I have on there. Looks like if I'm going to make it, it's going to be tight. Trying not to rub on the enameled portion, but you can't help doing it a little bit. Wow, that's tight. Okay, I'm going to grab this, maybe with a pair of pliers, squeeze it into that hole. We may not have a choice, we'll have to go with that. That's very tight. I think I was supposed to make a much looser coil than that. Maybe only most of the way of a turnaround instead of a full turn. It's 2 turns really. Maybe we'll get double the voltage out of this, who knows. I'm gonna have to get this real hot. I can't put too much pressure on it because if I bend the board downwards, it'll be leaning on the secondary winding, which is the really thin one, and break it off the board. I don't want to do that, because as soon as that cylinder, if it falls off the board, that's going to break the enameled wire. There we go. Look at that, just barely. I hope it doesn't arc over. This is 2 turns. Very interesting. I also have something special for you guys. I actually busted out the macro lens that I typically use to make my thumbnails, and I will be shooting this at a different angle. So once it's going, I'll have to not move, because the focus on a macro lens is razor sharp. It only takes a millimeter or so of space in focus. 1, 2, 3, just assembling the little feet here. And this kit comes with a neon, which is good because I don't think I have any CFLs left. Could have tried to light some CFLs with this kit, but I don't have any left. I think I stripped all the parts out of them, like in those previous videos. Like this. Okay, and now the, whoop, there's something flying. I'm going to take all these little pieces of metal away. Last thing is the knob for this switch. But if you guys think I am crazy enough to put my hands anywhere near this thing while it's active, you'd be mistaken. Is that on there properly? There we go. Now it's on there properly. I'm going to guess that's on. Alright. I'm going to prop this little thing up. Okay, now I'm going to set the focus of this camera, and I'm going to set the focus of the macro camera. And I'm using a, I don't know if you can see that here, 12 volt 4 amp plug pack. It's the one I typically use for my benchtop power supply. So there we go. Switch is on. Hopefully no residual voltage was in there. Okay, I'm going to move this away. I will set the focus of the cameras and bring you back. So this is actually take 2. It didn't do anything the first time, so I suspected it was the secondary winding that's actually not soldered properly to the bottom. So that's not L1, it's actually L2, the little fine wire. So let's give this another shot here. So contact. I don't see anything happening on either camera. I've got both cameras set up. Just going to try to hit the switch here. Oh, if I turn it, the switch in the upward position, the LED inside seems to be active. It is. I do not see any corona discharge though. It's very interesting. Not quite sure what the problem is, but I will bring a neon light closer and see if we can get it to light. Oh yeah, look at that. Don't know if you can see that. That's excellent. It is definitely lighting the neon lamp. Wow. That's pretty neat. No corona discharge though. I'm going to try to flip off the lights and see what happens. A little bit less light there. Carefully going around to pull out my big light. I don't see a corona discharge. this does say 12 volts. I'm only seeing the LED from the top. I'm not seeing anything akin to... Oh, wow, look, there it is. There was a tiny little bit there. Whoa. Look at that. I'm not sure if you're really seeing this, but it's dimming the lights in the LED. It's also getting really hot. You can see the smoke coming off of it. I wonder if the air in here is too dry to give us a proper arc. There we go. It's making a little bit of noise too. Wow, look at that. Huh. So that is working in one way or another. Look at that. I wonder if I can get it something pointier even to discharge to. There we go. Look at that thing. It says it's a 12 volt kit. Oh, it's getting hot. Look at the smoke coming off of that. It says the kit is for 12 volts, but I'm not sure about that. This is definitely lighting though. Look at that. That's pretty cool. Oh, burning off the coating here, but yeah, that's pretty awesome. So the switch has to be in the up position. It's in the down position, it doesn't really work. Get it to jump to the pliers, I think. There it goes. It's making a pretty disconcerting noise. That's pretty cool. I don't think I would touch it with my hands. Let's see what happens if I shut off the switch and back on. So off, back on. You really need to come in close there. Well, that's pretty freaking awesome. Well, that's it. I didn't die. I made it. Made it just fine. Is this warm at all? It's a little hot, but not too bad. Ooh, heatsink is very... wow, heatsink is very hot. I'm actually wondering if 12 volts, 4 amps is not quite enough. Yeah, because the primary winding is definitely warm to the touch. So I believe I would have to actually get a higher amperage supply for this, but then we could probably get the real Corona discharge. But yeah, this is freaking awesome. So I want to thank Neil's Hobby HQ for sending this to me. And I also want to thank my Patreons for just being awesome human beings. If you guys want to send a kit to me for me to try out, you can go into the channel description page and probably in the description of this video. And there you'll find my P.O. box, and you can send me stuff. Just note that whatever you send me is not a guarantee that I'll build it or look at it, but I mean, usually I will. And unless it's something, you know, egregious or some sort of prank, then I probably won't. And I probably won't acknowledge you. But other than that, I think you guys are pretty freaking awesome. So if you feel like it, there's the address. Also, my Patreon link will be in the description if you want to help support me like that. And other than that, thank you so much for watching, and I will catch you next time.